Worksheet 3B material properties, and in this case they give us multiple normal stress and normal strength curve for different material from 1060 shear steel, 1045 hot rolled steel, aluminum structural steel, magnesium, and clear birch. So from that we asked a few questions, not multiple, not few. The first one is, what is the yaw modulus of 1060 CR steel? So what is 1060 here? If you recall the equation to find out the yaw modulus, E is equal to sigma over the normal stress over normal strain, and in the linear portion in the elastic region of this. So from, if we get it at 0.1%, 0.1%, why 0.1, as you can see from the strain inch over inch, that is 0.01, it means 1% with that scale. The blue point in there is 0.1%, and go up to find the correspondent here, correspondent sigma, so it's about 30 ksi. So from that we can plug in 30 ksi divided by 0.1%, so it will be 0.110, because this, as you can see, this is 0.01, so that it will be 0.1%, 0.001, or 0.1%. So from that we can go ahead to find out. This one is 30,000 ksi for that steel. That A. B. What is the ultimate strength of 1045 steel? 1045 ultimate strength, so that the maximum stress of this. So it will be that point there, and find out the vertical one of the maximum stress. So from that is about, you see, a little bit above 110. So approximately that is about 110, more than 10, so about 113 ksi based on the graph we have. The next, C, proportional limit of 20, 20, 40 for aluminum. So where aluminum, the one in the middle here. Proportional limit. So in the region that they have a linear portion between the relationship of strain and stress. So as you can see, for that aluminum is somewhere stop here, or go back, it will be proportional limit. So from 0 to that point. So if we break down here, that is about between in the middle of 40 and 50. So let's get that is proportional limit is 45 ksi. And the D, what is the yield point or the yield stress of the structural steel there? What is the yield point? So the yield point is the point that the body begin to yield it, right? So structural steel begin to yield, so it's somewhere, let's put it the red here, so begin to yield somewhere here, and then you see the horizontal line go very far, and that's start of the horizontal portion of the curve. So that a little bit below 40, so we get, you can say it 40, or to be conservative it can be get it 39. KSI for sigma yield, and apply the similarly, but this one they ask us also the yield stress, so both D and E are yield stress, but for the, in this case, aluminum, and using 0.2% permanent offset, 0.2% aluminum. And as you can see, why we use the 0.2%, because the proportional, the yielding portion, the horizontal portion of the curve for aluminum is cannot visible, cannot see it in that curve, so that we have to use a proportional limit. We have to use the 0.2% method, 0.2% method, 0.2% offset method. So 0.2 it here, 0.2, that is 0.01, so 0.2%, let's put the red here, 0.2%. That point is 0.2% or 0.002. And make a parallel to the aluminum, make a parallel to aluminum. So the aluminum, you see that 2024, so make it parallel like in there. A human hand without the ruler, hopefully it's perfectly parallel to that proportional limit what it cut here. Look at on the lab, whatever happened there, whatever see there, it will be the proportional limit. So that one is about 50, so you can get that one is 50 KSI, kip per square inch. You get that, right? So yield stress basically can find either directly from graph, just like steel in the body, or if the horizontal portion of the curve is not visible, difficult to see in the curve, then you use the 0.2% offset method, 0.2% offset method. For example, aluminum in this case. Now, there are a few multiple choice question in here. Which of these material is the strongest? G, which of these is the most ductile material, and why? And there until K. So that is, go back to the lecture, go back to here with the material properties to measure stiffness, Young modulus, to measure resilient area under the elastic portion of the curve. For the toughness, area under the entire curve. The strength, ultimate stress. And then ductility, large rupture strain. Brittleness, small rupture strain. So F, which of these material is the strongest? Why? 1060 CR steel, aluminum, and magnesium. So that's strongest measured by the ultimate strength. So you can see the ultimate strength of the steel is about 96 KSI. If you go there, go to the, and then for aluminum, there is about 64 KSI, and the magnesium is somewhere here. Go there, it's about 32. So of course that is the highest ultimate stress for these three material. Absolutely, that is 1060 CR steel. G, which of these material is the most ductile material, and why? And as you can see that, say why, let's have to explain why, because that is highest sigma ultimate. Which of these material is the most ductile material, and why? To go back to the note, ductility measure the large rupture strain. Large rupture strain. Go back to here. Large rupture strain in here. G. Rupture strain for structural steel. As you can see, go far out here. It's almost 24.24 inch over inch, and that among all of this material on the curve that we have, the structural steel is the highest rupture strength. So from that, as you can see, compared to 1045 magnesium, it will be the structural steel. So with that, we can have structural steel. Why? Because that will be the largest rupture strength, epsilon r. Continue. Which of these is the most brittle material? So it's the opposite of the ductile. It will be the brittle. So the smallest epsilon r, the normal rupture strength. Aluminum, 1060 CR steel, and 1045 HR steel. So the smallest aluminum, so it's about 0.1. You see that? Rupture strength for aluminum. For CR steel 1060, CRC 1060, it about go down here, so it's about 0.023, and then the next one is 1045 steel. So with 1045 steel is more than 0.2, right? So up here, so from that we can say that should be the 1060 CR steel. 1060 CR steel. Why? Because that is the smallest rupture strength. Next, which of these material is the most resilient? Resilience is what? Measure the area under the elastic curve, elastic portion. Resilient area under the elastic portion of the curve. So from that, go back to here. Resilient, most resilient area under the elastic. So 1060 steel, 1045 HR steel, and structural steel, and elastic portion that you can see now, 1060 CR steel, structure, and HR steel. They all in the same line in the proportion limit, but you see the areas here, the height of the 1060 steel go up in the largest portion is up there, almost 70 there. Go down there. So that the area under that curve is the biggest compared to 1045 HR steel and structural steel. So from that we can say the 1060 CR steel is the more resilient because the largest area under elastic region. Next, G, which of these is the toughest material? Go back, measure area under the entire curve. So go back here. We have structural steel, 1060, and 1045 HR steel. So 1060, the area under the elastic limit, that much. Right? So not much. And then 1045 HR steel, the area under the elastic limit, that quite big. The whole curve there with that limit, area under that curve. And then the next one is structural steel. It's big, also big. So the structural steel, the area under that black line and that portion. But compare all of those three, and you can see the area under the 1045 HR steel is the largest in here. So that material, we call it the toughest in here. So that it will be the 1045 HR steel, because the largest area under the entire curve. Next, which material is the stiffest? So measure the stiffness of that material is the Young modulus. See that there? So go back, stiffness. So here, for the Young modulus, we have structural steel, .1060 CR steel, aluminum, and clear birch. So .1060, aluminum, and clear birch. So as you can see, those three, the .1060 steel have the highest slope in the proportion, highest slope. When it highest slope, as you can see, whatever the same amount that you go horizontal, it means the strain. The vertical component is the biggest, and that basically measure the Young modulus. And from that, because the highest slope in here for this one is the highest slope, largest slope. And when it largest slope, as you can see, you have max Young modulus. So from that, we can see here, definitely the answer will be structural steel, because they have the largest or greatest Young modulus, or modulus of elasticity. So with that, we done for 2 problems for today's class.